Have you ever wondered what truly happens in the quiet frontier, where the sun's warmth fades into the cold breath of the galaxy? It's a region so distant that light itself grows tired on the journey. A place where silence has its own weight, and where two small travelers launched decades ago continue drifting through the dark. Tonight, let's settle into that stillness together, the kind of silence that feels like the exhale of the universe itself, as we follow the faint signals of a machine older than most people alive today. Out there, far beyond the familiar planets, a soft hum of static once carried our voice through the void. Then, without warning, that whisper began to unravel. The signal weakened, patterns dissolved. And for the first time in nearly half a century, Voyager 1, the spacecraft that had seen Jupiter's storms, Saturn's rings, and the pale blue glow of home, slipped into a hush that scientists had hoped they would never hear. A silence so complete that it felt like the closing of a book mid-sentence, leaving only the uncertainty of what had vanished into the dark. Yet even in that void, human persistence refused to fade. Engineers sifted through fragments of corrupted memory, piecing together remnants of code like archaeologists brushing dust from ancient stone. Hour by hour, command by command, they reached into the darkness with nothing but hope and mathematics. And then, after months of waiting, listening, recalculating, and sending signals that took nearly a full day to cross the gulf between stars, a faint pulse returned. A fragile heartbeat from the edge of the solar system, carrying mysteries no one expected. What did that returning whisper contain? Why does the place where our sun's influence ends behave so strangely, contradicting decades of prediction? And what secrets did Voyager detect in that boundary where cosmic winds collide, twist, and reshape the very structure of space? These are the questions that invite us deeper tonight, not with urgency, but with a quiet sense of awe, as if we're sitting beneath a sky that has only just begun to reveal its oldest stories. Before we drift further, if these calm explorations help you unwind or offer a peaceful way to end your day, leaving a like and subscribing to the channel helps others find their way here too. Slowly, gently, one sleepy traveler at a time. Thank you for being part of this quiet corner of the cosmos. Now, let's step into the long twilight beyond the planets, where our tiny Voyagers continue their silent journey. We'll begin with the first ripples of solar wind that carry us outward toward the strange frontier that awaited them. The story of Voyager's journey begins with something surprisingly gentle, a continuous breath from the sun that streams outward in every direction. This flow is so soft that you'd never feel it on your skin, yet strong enough to shape an entire bubble around our planetary neighborhood. It carries charged particles, magnetic fields, and a memory of every flare the sun has ever exhaled. For the Voyagers, this breath became the first current pushing them toward the unknown, as if the star that launched them was giving a final, reassuring nudge into the deep. At its core, the solar wind is a river of electrons and protons heated to extreme temperatures, escaping the sun's gravity because they move too fast to be held in place. NASA instruments aboard countless missions, from Parker Solar Probe to SOHO, have measured its changing rhythms for decades. Near Earth, this wind travels at hundreds of kilometers per second. Farther out, it slows as it stretches thin, but it never stops. It's the quiet engine that inflated the heliosphere, the vast protective bubble that Voyager would eventually leave behind. The movement of this invisible river can be pictured as a shimmering veil, slowly drifting across an endless stage, illuminated by sunlight and carried by nothing but its own momentum. Even though it is made of particles too small to see, the wind moves like a soft fabric being pulled through space. It ripples with storms from the sun and glows with the faint echo of magnetic waves. To imagine the Voyagers drifting through this medium is to imagine specks of dust floating inside a beam of golden light, following currents older than humanity itself. Every so often, thinking about the solar wind feels like reflecting on a lifetime of small pushes, moments that guide us forward without us even noticing. A decision made lightly, a conversation that lingers, an unexpected chance that sets everything into motion. The Voyagers drifted outward because of a force they could neither see nor control. In much the same way, we often move through life guided by subtleties that only make sense when viewed from a far distance, long after the moment has passed. As the Voyagers continued outward, the wind around them began to thin. What once felt like a steady current became a faint whisper. Scientists studying telemetry from both spacecraft could see this change as a drop in particle density and a subtle shift in magnetic orientation. The heliosphere is not symmetrical. It swells, bends, and twists as the solar wind responds to flares, eruptions, and long-term solar cycles. Voyager's instruments captured this dynamic behavior with incredible precision, revealing a frontier that behaves more like a living membrane than a static boundary. Far out from the sun, the solar wind slows to subsonic speeds, forming what researchers call the termination shock. Here, the particles crash into the interstellar medium and pile up, like waves curling at the edge of a shore. Voyager 1 crossed this region in 2004, and Voyager 2 followed nearly 13 years later. The timing difference puzzled astrophysicists who expected both to cross near the same distance. Instead, the sun's breath behaved like a tide, advancing dramatically during some periods and receding during others, reshaping the frontier in ways that defy simple models. To visualize this place, imagine a vast ocean where the currents from one world meet the currents of another. The solar wind arrives like a warm tide, expanding outward for billions of miles. Beyond it flows a colder, denser sea of interstellar plasma. Where they meet, the boundary behaves like a shimmering, wavering horizon, constantly shifting under invisible pressures. If the heliosphere were visible, this region might look like the meeting of two vast atmospheric fronts, one sculpted by our star, the other sculpted by the galaxy. Thinking about this boundary invites a quiet recognition that even the spaces around us are shaped by opposing forces. The sun pushes outward, the galaxy presses inward, and somewhere in the middle is a place of transition. Life often mirrors this balance, moments where we're caught between what we've known and what lies ahead. Neither space is wrong, both shape us, and at the frontier, transformation becomes possible. The Voyagers drifted into that liminal zone unaware, but their instruments felt the tension of two competing worlds. The final stretch of the heliosphere contains turbulent magnetic eddies, compressed plasma, and patches where the solar wind slows almost to a halt. Instruments aboard both spacecraft detected strange fluctuations in particle energy, as if they were moving through an environment that was constantly rearranging itself. Scientists at Caltech and JPL studied these readings carefully, comparing them with predictions from decades of theoretical models. Each new measurement forced revisions to our understanding, revealing that the sun's reach is far more dynamic than anyone expected. Wave structures appeared in the data, rising and falling as though the heliosphere were breathing. Some waves spanned distances greater than the orbit of Saturn. Others pulsed unexpectedly, hinting at shocks from distant solar eruptions that had taken years to propagate outward. For Voyager, this region was a place of gentle chaos, energetic enough to reshape the particle environment around it, but quiet enough that the spacecraft could drift through unscathed. Every reading transmitted across billions of miles added to a portrait of a frontier that behaved like a cosmic tide pool. The beauty of this region isn't in its violence, but in its strangeness. The sun's wind isn't fading smoothly. It is negotiating with the galaxy. The heliosphere bends, compresses, stretches, and distorts like a translucent bubble suspended in a flowing river. Voyager recorded these dynamics patiently, frame by frame, revealing that the space surrounding our star is anything but empty. It is a landscape of pressures, movements, and boundaries, subtle and ever-changing, shaped by cosmic weather from both inside and outside. People sometimes imagine the edge of the solar system as a line drawn cleanly on a map. Voyager showed that this line behaves more like the shifting border of a cloud, sculpted by unseen winds. The spacecraft drifted through regions where energetic particles surged, where magnetism twisted unpredictably, and where previously unknown plasma interactions emerged. Each discovery challenged assumptions that scientists had held for decades. The frontier was not tidy. It was full of surprises waiting to be noticed by a machine that had already lived far longer than intended. Even now, the termination shock remains a subject of fascination. Its distance from the Sun fluctuates by billions of miles depending on solar activity. Some models once suggested it should be nearly spherical. Voyager proved it to be elongated and irregular. The two crossings, 2004 and 2017, were separated not by a neat difference, but by a landscape that changed dramatically between them. This unpredictability hinted that the Sun's influence on space is much more like weather than architecture, with storms that reshape its reach across the decades. Standing metaphorically beside Voyager in this region encourages a sense of humility. We learn that even the boundaries we believe to be stable may shift under pressures we never considered. The cosmic forces shaping the heliosphere are enormous, but their changes are subtle, gradual, and often hidden until a small machine, sailing alone for nearly half a century, stumbles into them and sends back a message. It's a reminder that discovery often begins with the quiet willingness to keep moving, even when the map ahead is uncertain. The solar wind's weakening flow eventually brought Voyager to the threshold of something entirely new. At this frontier, the Sun's authority waned, and the galaxy began to assert its presence. The spacecraft drifted toward a realm no mission had ever entered, where every reading would be the first of its kind. This delicate transition marked the beginning of a journey into a place where even light behaves differently, an entrance to a larger, older sea that had waited for billions of years to be studied. Voyager's data showed that the solar wind at these distances grows thin enough that its particle pressure becomes comparable to the pressure of the interstellar medium beyond. This balance forms the outer boundary of the heliosphere, a place called the heliopause. Before the Voyagers arrived, scientists assumed this region would be relatively smooth. Instead, the mission revealed a boundary full of ripples, folds, and gradients. The Sun's breath meets the galaxy's winds not gently, but with the subtle friction of two vast colliding influences. Imagining this boundary brings to mind a curtain fluttering at the meeting point of two opposing breezes. It is neither here nor there, suspended in a place of transition, constantly reshaping itself. Voyager's sensors captured this dance not in images, but in fluxes of particles and magnetic patterns, each one a signature of the shifting frontier. The spacecraft couldn't see the waves themselves, but the data told the story. The boundary moved, twisted, and pulsed as if responding to unseen tides pulling from distant corners of the galaxy. Thinking about this flow between the Sun and the galaxy encourages a contemplative pause. We often imagine ourselves as separate from others, from the world, from the universe, but boundaries are rarely firm. They breathe, they evolve, they respond to pressures we barely notice. In the same way, The edge of the solar system isn't an end, it's a gradient, a transformation. Voyager drifted through this region without ceremony, marking humanity's first encounter with the place where the influence of our home star begins to fade. The approach to the heliopause brought subtle changes in particle composition. Solar particles slowed dramatically, crowding densely against the boundary. Meanwhile, energetic cosmic rays from the galaxy became more abundant. The data suggested a tug-of-war between two fields, one waning, the other strengthening. Voyager 1 observed this interplay for months, tracing a delicate transition zone thicker and more textured than expected. The spacecraft was entering a realm shaped not by the sun, but by the deep ancient currents of the Milky Way itself. These currents are formed by supernovae, stellar winds, and the motion of plasma threaded through interstellar magnetic fields. Unlike the solar wind, which reflects the moods of a single star, the interstellar medium is a product of countless cosmic events scattered across the galaxy. Voyager's arrival here marked a profound shift in perspective. For the first time in history, a human-made object touched the space between stars, a place defined not by the familiar rhythms of our sun, but by the aggregated memory of 1 million distant lives. The moment Voyager crossed into this domain was detected not by a photograph or an image, but by a rearrangement of energy levels in its plasma wave instrument. It sensed a sudden rise in electron density, evidence that it had left the warm bubble of the heliosphere and entered colder, denser plasma. This reading confirmed something monumental. The spacecraft had stepped into interstellar space. Humanity had extended its reach beyond the protective threshold of the sun and into the great open sea that fills the galaxy. Thinking about this transition evokes the image of a traveler stepping off a familiar shore and placing a foot onto a new continent. The moment is quiet, almost unremarkable in its physical sensation, yet monumental in meaning. The Voyagers didn't feel the crossing. They drifted. And yet, with that drift, humanity became an interstellar species, not in body but in presence. The boundary they crossed is one we can't follow physically, not yet. But through their fragile signals, we are able to understand a place that existed long before us and will remain long after we are gone. Even after entering interstellar space, the spacecraft remained tethered to home by a single thread, radio waves stretching across nearly 24 billion kilometers. Every message took more than 22 hours to reach Earth, and another 22 hours for a response to return. Yet despite the immense distance, a dialogue continued, a faint conversation carried across the cosmic dark. Through this whisper, the spacecraft continued to reveal truths about a frontier shaped by forces we barely comprehend, a place where the galaxy's breath becomes the dominant sculptor of space. The frontier Voyager entered is not empty. It is a realm of low-density plasma, shaped by remnants of ancient stars and threaded with magnetic fields that wander unpredictably. Measurements showed that this environment is cooler yet denser than the solar wind it replaced, contradicting long-held expectations. Theories predicted a different composition, different temperatures, different densities, but reality, captured through Voyager's quiet persistence, proved more nuanced. Each new reading reminded scientists of how little we truly know about the space between stars. This region also amplified cosmic rays, high-energy particles accelerated by cataclysms across the galaxy. As Voyager drifted deeper, the influx of these particles increased, revealing patterns shaped by distant explosions and magnetic turbulence. These cosmic rays are ancient messengers, carrying the signatures of supernovae and bursts of energy far older than our species. Their presence added another layer of complexity to the frontier, demonstrating that interstellar space is a vibrant environment, filled with motion even in apparent stillness. Scientists studying these patterns realized the heliosphere acts like a shield, deflecting many cosmic rays from reaching the inner planets. By crossing the boundary, Voyager exposed itself to a cosmic environment far harsher than anything inside the solar system. Yet the spacecraft endured, continuing to transmit data despite aging instruments and dwindling power reserves. Its resilience became not just a scientific achievement, but a symbol, an example of how something small and fragile can survive in places never meant for it. The crossing into interstellar space marked a profound scientific milestone, but also an emotional one. It showed that exploration doesn't require speed or strength, only persistence and an open path. Voyager had no propulsion system capable of major course corrections, no shield to protect it from the unknown, no expectation of lasting half a century. It drifted, carried by momentum and guided by careful planning. That drift proved enough to make history. The spacecraft didn't conquer the frontier. It simply arrived quietly, gently, faithfully. Voyager's journey beyond the sun's influence forms the first foundation of our exploration tonight. The strange shifting boundary it crossed holds clues to how our solar system interacts with the broader galaxy. It also marks the beginning of everything the spacecraft would later encounter: mysterious signals, unexpected energies, and phenomena that still puzzle scientists. As we move forward, we follow Voyager's path not with urgency, but with the same steady patience that carried it across billions of miles. And with that, we drift deeper, toward the next mysteries waiting in the quiet beyond. A region filled with quiet turbulence awaited Voyager as it moved farther from the sun's fading influence. While the space around the spacecraft seemed utterly still, its instruments sensed currents and pulses that felt almost like whispers from a distant ocean. Magnetic fields shifted unpredictably, and plasma densities rose and fell in patterns that didn't match any previous model. This place wasn't a void. It was alive with subtle motion, as if the galaxy itself were breathing around the tiny visitor drifting through its threshold. Researchers expected the frontier to be chaotic, but the data revealed something even stranger: a background hum that persisted regardless of solar activity. This faint vibration was detected through fluctuations in the plasma wave instrument, which measures changes in the density of charged particles. The tone didn't resemble solar wind disturbances or typical interstellar effects. Instead, the sound carried a steady signature, like a perpetual resonance spread across vast distances. Scientists compared it to a faint echo, an interstellar choir humming in the dark. Describing this hum is like imagining a low, continuous note played by an ancient instrument, one that vibrates not through air, but through mist-thin plasma stretched between stars. It doesn't rise or fall dramatically. It lingers, patient and unwavering. Voyager's sensors captured it as electrical oscillations too subtle for human ears, yet rich with meaning. If translated into sound, the tone would resemble the gentle ringing of crystalline, suspended in a space untouched by wind or gravity. It is the galaxy's quiet music, played on strings made of charged particles. Hearing about these vibrations encourages a moment of reflection. Some signals in life are loud and unmistakable, demanding immediate attention. Others are soft, steady, and easily overlooked, yet they shape everything around us. Voyager registered the faintest patterns because it kept listening, even when nothing obvious seemed to be happening. In a similar way, the quiet influences that guide our lives often emerge only when we slow down enough to notice them, allowing subtle truths to surface in the silence. When solar storms travel outward, they send shocks through the heliosphere. These shocks sometimes reach the frontier and push into interstellar space. Voyager recorded sudden bursts in plasma density as these waves passed by, months or even years after leaving the sun. The timing puzzled researchers. The shocks seemed to propagate with unexpected strength, maintaining their structure across billions of miles. This suggested that the space beyond the heliosphere isn't as empty as once believed. Instead, it behaves like a medium capable of carrying disturbances far more efficiently than models predicted. A shockwave drifting through interstellar plasma can be likened to a ripple traveling across the surface of a vast dark sea. It carries the memory of the event that created it, long after the source has quieted. Voyager felt these ripples as gentle pressure changes, each revealing a piece of the environment surrounding the spacecraft. While too subtle to harm the probe, they offered invaluable data, evidence that the galaxy holds its own pulsing rhythm, stirred by distant storms and ancient explosions. These encounters often lead to moments of contemplation about how distant events can shape worlds far removed from their origins. A supernova exploding light years away can send a shockwave through interstellar space that eventually brushes against the solar system. The boundary we consider home is not separate from the rest of the galaxy. It is part of a vast network where everything influences everything else. Voyager's journey revealed that isolation is an illusion. Every region of space is connected by invisible threads of energy and motion. Another strange phenomenon puzzled scientists. The density of interstellar plasma surrounding Voyager was far higher than predicted. Models suggested that the environment beyond the heliosphere would be thin and sparse. Instead, measurements showed dense, cold plasma exerting surprising pressure. This contradicted decades of expectations and forced researchers to re-evaluate assumptions about the structure of the local interstellar medium. The galaxy, it seemed, had more complexity than even the most sophisticated simulations had envisioned. This plasma behaves almost like a delicate mist, dense enough to interact with the spacecraft's instruments, yet too diffuse to see or touch. It flows slowly around the heliopause, shifting as magnetic fields weave through it. Voyager's sensors translated this invisible world into data points and waveforms, each revealing a little more of the unseen environment. The interstellar medium is not uniform. It is textured, layered, sculpted by ancient forces that left their marks long before the solar system formed. There is something poetic about drifting through a place where the past leaves fingerprints on every particle. Supernova remnants, stellar winds, and magnetic turbulence mix together to form this plasma sea. Each region carries a different history, some shaped by dying stars, others influenced by molecular clouds or shock fronts. Voyager moved through these stories without ever sensing the grandeur surrounding it. Yet through its instruments, humanity glimpsed a layered tapestry woven from cosmic memory stretching across the galaxy. Reflecting on these discoveries invites a quiet appreciation for how much of existence is shaped by history we never witnessed. The atoms in our bodies once belonged to stars. The magnetic fields surrounding Earth were forged in the planet's molten heart, and the subtle flows of interstellar plasma carry echoes of events billions of years old. Voyager's journey through this environment feels like a symbolic return to origins, a passage through the ancient materials from which everything, including us, was made. Among the most puzzling readings was the discovery that the interstellar magnetic field near the heliopause was stronger than anticipated. Instruments showed that its strength was 2 to 3 times the predicted value. This revelation forced researchers to rethink how the galaxy's magnetic environment interacts with the solar system. A stronger field exerts more pressure, shaping the heliosphere's boundary more aggressively and influencing the behavior of charged particles crossing between regions. A magnetic field at these distances can be imagined as a fragile lattice that fills the space between stars. It doesn't look like the fields we picture around magnets on Earth. Instead, it meanders like faint lines of tension suspended in the dark. Voyager traced variations in this lattice as it drifted, sensing slight rotations and fluctuations that revealed how interstellar currents weave through the galaxy. These measurements provided rare clues about the structure of space far beyond any map humanity had drawn. Acknowledging that such delicate forces shape the galaxy encourages humility. The magnetic fields sculpting interstellar space are ancient, shifting slowly over millions of years. They respond to supernovae, stellar winds, and the motion of the galaxy itself. Voyager's tiny presence within this environment reminds us that exploration doesn't diminish mystery, it deepens it. With every discovery, the horizon expands, showing that even the simplest assumptions require re-evaluation when confronted with reality. The signals Voyager detected in the frontier region weren't limited to plasma vibrations or magnetic fluctuations. Occasionally, the spacecraft registered sudden drops or spikes in energetic particles, patterns that didn't match solar activity or known interstellar events. Some researchers proposed these anomalies were caused by turbulence in the local interstellar cloud, the region of space through which the solar system is currently traveling. Others suggested they might reflect deeper oscillations in the galaxy's magnetic structure. Thinking about these unexplained patterns is akin to pondering faint footprints on an untouched landscape. The cause isn't immediately obvious, but the imprint is undeniable. Voyager's sensors captured signatures of forces humanity can't yet fully interpret. Each anomaly invites new hypotheses, new simulations, and new attempts to reconcile theory with observation. It is a testament to how exploration often reveals more questions than answers, and how progress thrives in the unknown. The strange readings also highlighted the resilience of Voyager's aging instruments. Built in the 1970s, the spacecraft wasn't designed to withstand the environment of interstellar space, yet its detectors continued to register faint signals with astonishing precision. The data returned from this remote region carries the reliability of a mission conceived with meticulous care, crafted by engineers who would never live to see the spacecraft reach this frontier. Their work endures, carried on a stream of radio waves crossing billions of kilometers. This endurance adds a quiet emotional weight to the mission. The Voyagers weren't designed to outlive the people who built them, let alone operate half a century after launch. Yet they continue to send data, each transmission a fragile reminder of what humans can accomplish when curiosity outweighs fear. The spacecraft became an extension of our senses, a way of touching the galaxy without leaving home. And through that touch, the universe reveals itself not as empty, but as intricate, textured and alive with phenomena waiting to be understood. As Voyager drifted deeper into the interstellar medium, its observations became even more valuable. Every fluctuation in particle density, every magnetic shift, every subtle ripple helped shape a clearer map of the space between stars. Models improved, theories evolved, and researchers gained insights into processes that had once existed only as equations. The spacecraft's presence in this region is a reminder that discovery doesn't require dramatic action. It requires patience, precision, and a willingness to listen to what the universe quietly reveals. Drifting farther from the Sun's domain, Voyager continued to collect data that challenged expectations. Some readings aligned with predictions, while others contradicted everything scientists thought they understood about the heliosphere's interaction with interstellar space. Each contradiction forced revisions, expanding theories of how the galaxy behaves on small scales. The mission showed that even the most advanced models need the grounding of observation, a truth that has guided science since its earliest days. Despite the unknowns, Voyager's path remained steady. It followed no active propulsion and carried no destination in its memory. Momentum alone carried it onward. That simplicity gives the mission its poetic quality, a silent traveler continuing forward, propelled by physics and guided by curiosity. The spacecraft has become a symbol of persistence, a reminder that steady movement, even when slow and unglamorous, can lead to horizons no one imagined possible. Through all the strange signals and unexpected discoveries, Voyager's journey reveals something profound. The edge of the solar system isn't a boundary, it's a beginning. The strange phenomena the spacecraft detected mark the transition into a domain shaped by forces older and larger than our Sun. This realization transforms the frontier into a threshold, one that invites deeper exploration. Following Voyager's path means stepping into a region where every measurement becomes a first step, every observation a new clue, and every quiet signal a reminder that the galaxy is full of mysteries awaiting patient discovery. Now, with these foundations set, the next steps guide us deeper into the peculiar revelations waiting in the silent dark beyond. Far from the warmth of the inner planets, the Sun still stretches its influence outward in the form of the solar wind, a stream of charged particles rushing through space at hundreds of kilometers per second. For decades, models suggested this wind would gradually weaken until it simply blended into the interstellar medium. Voyager's measurements, however, revealed something entirely different. Instead of fading softly into the cosmic environment, the wind struck a sharp or unexpected boundary, as though it had collided with an invisible wall sculpted by forces no one fully understood. The existence of this abrupt transition fascinated researchers. The solar wind behaved predictably for billions of miles, then suddenly changed direction as though deflected by the pressure of the galaxy itself. Voyager sensed this shift as a dramatic drop in particle speed, followed by an equally dramatic rise in magnetic turbulence. The location of the transition varied over time, shifting like a shoreline rising and falling with unseen tides. This instability contradicted long-held expectations and forced scientists to reconsider how the Sun interacts with its surroundings. Trying to imagine this boundary is like visualizing a translucent membrane floating in space, one shaped not by physical material, but by opposing flows of plasma and magnetic fields. On one side lies the realm of the Sun, filled with particles born from fusion and carried outward on the solar wind. On the other side lies interstellar plasma, older, colder, and influenced by the accumulated history of stellar explosions. The two regions meet, but they do not mix smoothly. Their interaction creates a dynamic surface that bends and flexes with cosmic weather. Thinking about this membrane evokes ideas of limits in our own lives, places where familiar forces begin to lose their influence, giving way to unfamiliar pressures. Boundaries often feel static, but in reality they breathe and shift, responding to internal change and external circumstances. Voyager showed that even cosmic borders are not rigid. They move, oscillate, and evolve. They are shaped by conflict and balance, by push and pull, just as human lives are guided by competing forces of comfort and challenge. Researchers once assumed that the heliopause, the outer edge of the Sun's influence, would be relatively smooth, but Voyager found the boundary rippled by immense waves, some spanning distances greater than the orbit of Earth. These waves form due to pressure changes in the solar wind, bursts from the Sun, and the constant flow of interstellar plasma pressing in from beyond. The result was a surface that undulated unpredictably, like a cosmic curtain fluttering in a breeze invisible to human eyes. Translating this movement into a mental image reveals a dynamic scene, an enormous, glimmering bubble being pressed from both sides, changing shape with each passing wave. Its motions are slow, majestic, and shaped by forces older than the planets. Voyager moved through this environment not as a conqueror, but as an observer, recording each shift with instruments sensitive enough to detect variations smaller than a whisper. The spacecraft revealed a boundary that behaves like a living structure, constantly responding to the cosmic winds that sweep across it. Understanding this hidden motion brings attention to the interdependence of all things. The sun's influence doesn't stop abruptly. It meets resistance from the galaxy, and that resistance shapes the very environment in which our solar system drifts. In a similar way, even the most powerful personal forces, our intentions, habits, and identities, meet boundaries shaped by the world around us. Voyager's discoveries echo an ancient lesson. Nothing exists in isolation, and every influence meets an equal, shaping response. Another surprise emerged when Voyager measured the temperature and density of plasma near the boundary. Predictions suggested a significant rise in heat as the slowing solar wind compressed against the interstellar medium. The expected temperature increase did occur, but not at the magnitude theorists anticipated. Instead, the energy seemed to disperse more efficiently than models allowed. The region remained cooler, thinner and more stable than expected, revealing a mechanism of energy transfer scientists had not yet identified. Visualizing this discrepancy is like imagining a cushion that absorbs impact far more effectively than its design suggests. The solar wind should have piled up at the boundary like traffic slowing before a bottleneck, generating heat and pressure. But instead, the particles seemed to slip away, diffusing into paths no one had mapped. This behavior hinted at microscopic processes involving magnetic reconnection, where magnetic field lines break and reform, dispersing energy quickly into the surrounding plasma. Reflecting on this puzzling behavior highlights how often the universe behaves with quiet complexity. Systems rarely follow simple, linear patterns. They conceal layers of interaction that reveal themselves only through observation. Voyager's findings demonstrate that even the most advanced theories must remain flexible, willing to adapt as new information emerges. The spacecraft's journey reminds us that understanding requires humility, patience, and openness to mystery. A further anomaly appeared in the magnetic readings. Instead of aligning neatly with the expected direction of the interstellar magnetic field, the local field near the heliopause exhibited unexpected twists. Voyager detected sudden rotations in magnetic orientation, suggesting turbulence or boundary instabilities. These twists persisted even after the spacecraft crossed fully into interstellar space, implying that the transition region was more chaotic than models predicted. This chaotic interplay can be pictured as delicate threads being tangled by invisible currents. Magnetic lines that should flow smoothly become distorted, bending in unexpected directions. Voyager traced these distortions with exquisite sensitivity, revealing a boundary textured with hidden motions. These insights provide rare clues about the nature of interstellar turbulence, a phenomenon that influences star formation, cosmic radiation, and the structure of galaxies. Such discoveries emphasize how fragile our expectations can be when confronted with the reality of nature. Humans often rely on simplified assumptions to navigate complexity, but the universe doesn't conform to simplicity. Instead, it reveals layers of behavior that challenge certainty. Voyager's findings illustrate how exploration often unravels ideas that once seemed solid, inviting deeper questions and more nuanced understanding. The spacecraft also detected differing particle populations near the boundary. Some particles behaved consistently with solar wind origins, while others appeared to come from deep interstellar space. Their energies and trajectories differed, and their interactions formed complex patterns. Understanding these populations requires decades of analysis, and even now, researchers continue to debate their origins. Voyager offered the first glimpse into this blended environment, a mixture of materials shaped by two vast realms meeting in a narrow zone. Imagining this mixture brings to mind a confluence of rivers, where waters from distinct landscapes merge into swirling, unpredictable patterns. Particles from the sun and particles from the galaxy interact, collide, exchange energy, and drift apart again. Voyager floated through this confluence, its detectors quietly registering each shift. The insight gained from this journey enhances our understanding of how energy and matter circulate through cosmic systems on scales far beyond human experience. Considering the boundary's complexity invites a moment of introspection about how different influences shape identity. Just as solar and interstellar particles mix in a delicate dance, individual lives are shaped by internal motivations and external forces. The edge between these realms can be turbulent, yet transformative. Voyager's passage through the heliopause serves as a metaphor for transitions that challenge existing models, forcing adaptation and growth. Even after crossing the threshold into interstellar space, Voyager continued to sense variations in particle behavior that suggested lingering influence from the sun. Solar storms, though weakened, still sent ripples through the plasma. These ripples traveled farther than expected, sustaining coherence across impossible distances. Their persistence indicated that the sun maintains a presence long after its dominant influence fades, echoing like a distant heartbeat in the dark. Imagining these ripples evokes a sense of enduring connection. Even at unimaginable distances, the sun's touch remains, carried by currents that drift through the cosmic sea. Voyager became a witness to this persistence, offering proof that influence doesn't disappear abruptly. It stretches across distance and time, reaching places far beyond where it was born. This continuity mirrors the enduring impact of actions and ideas long after their originators are gone. As Voyager drifted deeper into interstellar space, the spacecraft entered an environment shaped more by galactic forces than solar ones. Here, the density of plasma changed subtly but consistently, providing clues about the structure of the local interstellar cloud. The region through which the solar system travels is not uniform. It contains pockets of density, temperature, and magnetic strength. Voyager's presence within this landscape offered insights that static models could never achieve. Visualizing this cloud is like imagining fog illuminated by faint starlight, soft gradients of density forming layers and pockets, each shaped by ancient events such as supernova remnants or passing shock fronts. Voyager glided through these gradients, its instruments sensitive enough to detect changes that would go unnoticed by larger, less delicate probes. The spacecraft, though small, possessed a remarkable ability to reveal the subtleties of a world humans will never physically visit. The revelation that the solar system drifts through such a cloud expands our understanding of cosmic motion. Our home is not stationary. It moves through regions shaped by ancient history, each affecting space weather, cosmic rays, and atmospheric chemistry. Voyager's journey helps us visualize this motion as part of a larger story, a drifting system interacting with a vast galactic environment shaped by forces beyond imagination. These findings serve as a reminder that the universe is filled with boundaries that challenge assumptions. The heliopause, once thought to be a simple threshold, became a complex interplay of magnetic tension, particle flow, and dynamic structure. Voyager's passage through this environment offered humanity a glimpse into a frontier shaped by competing forces, a reminder that mystery thrives even in places science has long tried to define. With each anomaly recorded, Voyager demonstrated the value of listening deeply to the universe. Even the faintest signals held meaning, guiding researchers toward richer understanding. As the spacecraft continued outward, its instruments revealed a landscape shaped by power, delicacy and ancient motion. These clues prepared the way for exploring the region beyond, a domain where the galaxy begins to assert its influence fully, and where the strange signals Voyager detected would become even more intriguing. Long before Voyager reached the edge of the heliosphere, scientists believed interstellar space would be quiet, a cold, empty realm governed only by the faint push of cosmic rays and the drifting remnants of ancient stars. Instead, the spacecraft encountered a region alive with subtle motion. Its instruments captured fluctuations in plasma density that rose and fell like the swell of a distant ocean. These waves weren't random. They seemed to follow patterns shaped by forces extending far beyond the solar system's reach, challenging every expectation of what the interstellar medium should be. The first major clue came from the plasma wave detector. Normally, this instrument registers faint vibrations produced when charged particles oscillate in response to electromagnetic disturbances. As Voyager crossed the heliopause, the detector recorded an unexpected chorus. Long, smooth tones merged with sudden, sharp spikes, creating a structure that resembled the layered harmonics of a musical instrument being played by invisible hands. The vibrations were so distinct that researchers could directly calculate the density of interstellar plasma, something never achieved before Voyager's crossing. These plasma oscillations created a mental picture of space that felt nothing like emptiness. Instead of silent darkness, the interstellar medium behaved like an enormous resonant chamber. Each fluctuation in density created subtle shifts in tone, transforming the region into a kind of cosmic soundscape. Voyager's recordings, though converted into audible frequencies for humans, revealed a haunting environment where vibrations stretched and hummed across unimaginable distances, as though the galaxy itself carried a quiet murmur beneath its vastness. Reflecting on these vibrations evokes a sense of how even the quietest environments conceal hidden activity. Silence is rarely pure. It often contains layers of energy waiting to be noticed. Voyager taught scientists that emptiness does not mean inactivity. Just as moments of inner stillness can contain complex emotional currents, the interstellar medium, like the human mind, holds a subtle orchestra that requires attention and patience to understand. Further surprises emerged when Voyager's magnetometer revealed unusual magnetic structures. Instead of the smooth, gently curved field lines predicted by models, the spacecraft encountered abrupt twists. The lines seemed to rotate in unexpected directions, forming tangled regions that stretched for millions of kilometers. These irregularities hinted at turbulence, eddies and swirls of magnetic tension shaped by long-ago supernovae or by interactions between different interstellar clouds. Imagining these magnetic distortions is similar to watching ribbons twisting in the wind. Even without seeing the air currents directly, the shapes of the ribbons reveal their presence. Voyager's instruments acted like those ribbons, tracing the invisible motions of interstellar magnetism. Each sudden shift recorded by the probe helped piece together a deeper understanding of the forces threading through the galaxy's outskirts. Such turbulence is not merely a curiosity. It affects the movement of cosmic rays, the formation of stars, and the boundaries of stellar systems. Understanding it requires embracing complexity rather than searching for simplistic explanations. Voyager demonstrated this truth by encountering variations that defied decades of prediction. The spacecraft drifted through a region shaped not by uniform structure, but by a history of ancient events, each leaving its imprint in the magnetic landscape. The plasma waves themselves displayed additional mysteries. Some oscillations rose in frequency much faster than expected, suggesting encounters with shock waves traveling from distant supernova remnants. These shock waves compress the interstellar medium, sending ripples through space that maintain coherence even after traveling for hundreds of light years. Voyager detected these subtle traces, like sensing the aftershock of a distant thunderclap softened by time. Visualizing these shockwaves reveals a universe constantly reshaped by its past. Each massive explosion sends echoes through space, shifting magnetic fields and compressing plasma. Voyager happened to drift through several such echoes, recording their passage as gentle rises in frequency. Even though the original supernovae occurred long before humanity existed, their remnants continued to shape the environment surrounding our solar system. Thinking about these echoes invites reflection on how events from the past continue to influence the present. The universe carries memory in the form of waves, fields, and particles. Humans carry memory through choices, habits, and emotional imprints. Both forms of memory travel far, shaping circumstances long after their origins fade from sight. Voyager's detection of these ancient shockwaves highlights the continuity running through all systems. Another revelation came from the behavior of cosmic rays. Before Voyager's crossing, scientists believed cosmic rays would sharply increase in number once the spacecraft left the heliosphere. Instead, the rise occurred more gradually, with unexpected dips and spikes along the way. These variations suggested complex interactions between solar magnetic fields and interstellar fields, forming a labyrinth that influenced the paths of high-energy particles. Visualizing this labyrinth evokes the idea of currents winding through a maze. Particles move along shifting lines of magnetic tension, sometimes accelerated, sometimes trapped, sometimes redirected. Voyager followed these patterns like a leaf carried by overlapping streams. The spacecraft's data forced scientists to rethink how cosmic rays move through the galaxy and how the sun's influence persists far beyond its expected limits. The behavior of these rays raised intriguing philosophical parallels. Forces we cannot see often guide our paths. Circumstances, beliefs, and unseen pressures shape choices before we consciously notice them. Cosmic rays follow invisible threads woven through space, just as people follow threads woven through their experiences. Voyager's findings show that complexity often lies beneath apparent randomness, waiting to be uncovered. Temperature measurements added another layer of confusion. Voyager detected cooler regions, where models predicted high temperatures, and warmer regions where cooling should dominate. These inconsistencies pointed to energy transfer processes not fully understood. The plasma seemed to absorb and release heat in ways that contradicted standard predictions, implying interactions at scales below current theoretical models. Imagining these temperature shifts brings to mind a landscape where pockets of warm and cool air blend unpredictably. Instead of a tidy gradient, the interstellar medium behaved like a mosaic. Voyager drifted through patches shaped by past shockwaves, nearby clouds, or intricate magnetic structures. Each patch held a different story about the history of the galactic environment surrounding the solar system. These variations reinforced the idea that the boundary between the solar and interstellar realms is not a static shell, but a dynamic frontier. The region responds to solar activity, interstellar currents, and transient events like shocks from distant stars. Voyager passed through this frontier as a traveler who wanders from one weather system into another, sensing each shift with instruments sensitive enough to detect the faintest ripple. Contemplating these transitions reveals how delicate balance can be. The heliopause is maintained by a constant negotiation between internal pressure and external resistance. Remove one force, and the boundary changes shape. Increase another, and the frontier shifts outward. This interplay mirrors the balance humans maintain in their own lives, constantly calibrating between inner desires and external demands. Voyager's ability to detect faint electrical oscillations allowed scientists to estimate the electron density of the interstellar medium with remarkable precision. These measurements revealed that the density was higher than expected, another contradiction to long-standing theories. The interstellar environment around the solar system turned out to be denser, cooler, and more dynamic than previously believed. This realization redefined Earth's place in the galaxy. Rather than drifting through a uniform void, the solar system moves through a structured cloud shaped by ancient explosions and galactic tides. Voyager's presence in this cloud provided the first direct sampling of its conditions. The spacecraft continued to glide through gradients of increasing density, each revealing new aspects of the cosmic neighborhood humanity inhabits. Reflecting on this shifted perspective highlights how exploration alters identity. Learning the nature of one's environment reshapes understanding of one's origins. Voyager revealed that humanity lives inside a complex and evolving bubble, drifting through ever-changing regions of space. The solar system becomes not a static location, but a vessel traveling through a vast sea of interstellar activity. The way Voyager adapted to this environment demonstrates resilience. Its aging instruments continued to function despite harsh radiation, low power, and increasing distance. The spacecraft endured conditions far beyond its intended mission duration. This endurance mirrors how long-term persistence can reveal deeper truths, whether in science or in personal journeys. Voyager's survival turned it into a witness to phenomena no other mission has observed. As the spacecraft drifted farther, it encountered subtle changes in plasma frequency that indicated small fluctuations in density, fluctuations shaped by ripples traveling from the inner heliosphere. These ripples, generated by solar storms years earlier, traveled outward until they reached Voyager. Their arrival allowed scientists to map solar activity across enormous distances, demonstrating that the sun's influence remains detectable far beyond its expected boundary. These distant ripples evoke the image of a bell rung softly, its vibration traveling outward until it becomes nearly indistinguishable from silence. Voyager detected those last threads of resonance, offering proof that dynamics originating near Earth continue to echo across the galaxy. This persistence illustrates how even small forces can leave long-lasting imprints on vast environments. Ultimately, the discoveries from this region reshaped scientific understanding. The heliopause is not a clean threshold. It is a contested boundary shaped by pressure, turbulence, magnetism, and history. Voyager pierced through this frontier and revealed a place rich with motion, contradiction, and subtle beauty. With each anomaly recorded, the spacecraft offered another doorway into deeper questions that guided scientists toward the strange signals waiting beyond. As Voyager drifted onward, leaving the shifting frontier behind, its instruments opened a new chapter in space exploration. The spacecraft began to encounter conditions governed less by solar influence and more by galactic dynamics. In this territory, the signals it detected would challenge expectations yet again. Whispers carried across interstellar distances, filled with mysteries no one anticipated. Crossing deeper into interstellar space pushed Voyager into regions no spacecraft had ever entered, where familiar assumptions began to fail. The heliosphere's fading influence left the probe drifting through an expanse shaped entirely by the galaxy, rather than by the sun. Every instrument on board, no matter how old or limited, became a precious set of eyes. And as Voyager moved farther from the boundary, its sensors began to detect behaviors that stretched far beyond ordinary models of plasma physics. Early observations revealed a quiet backdrop pierced by sudden variations in charged particle density. These fluctuations occurred too quickly to be explained by standard turbulence. Even more intriguing, they appeared in clusters, brief intervals of intense activity surrounded by long stretches of near silence. Researchers initially suspected noise or interference, but repeated readings demonstrated consistency. Something in the interstellar medium pulsed with an unexpected rhythm. The nature of these pulses raised questions about what forces could influence plasma over such immense distances. Galactic magnetic fields typically shape charged particles gently, smoothing variations rather than intensifying them. Yet Voyager encountered sharp gradients, as though it were passing through thin layered structures, sheets of plasma that stacked on top of each other, like delicate pages drifting through the dark. Each sheet carried slightly different densities, temperatures, and magnetic orientations. Thinking of these sheets evokes the image of walking through fog that changes texture with every step. Some layers feel thick and cool, others thin and sharp. Voyager's trajectory seemed to cut through a similar patchwork of invisible boundaries, each formed by long histories of supernova shockwaves, ancient stellar winds, and the slow mixing of interstellar clouds. The spacecraft's movement transformed these structures into a sequence of discoveries. Further into this region, the spacecraft encountered an unexpected rise in low-frequency plasma waves. These waves followed patterns unlike those generated by solar activity. Their shape suggested origins far beyond the Sun, likely disturbances carried through the galaxy from distant, dying stars. Each wave carried memories of events millions of years old. Their energy stretched thin across unimaginable distances. Reflecting on these ancient echoes reveals how interconnected the universe truly is. A supernova that exploded before humanity existed still sends ripples that Voyager now drifts through. The present contains whispers of the past, just as human emotions often hold echoes of experiences long forgotten. In both environments, memory persists in subtle but powerful forms. One of the most puzzling findings came from the magnetic field readings. As Voyager moved away from the heliopause, researchers expected the magnetic field to gradually shift toward the orientation of the broader galactic environment. Instead, the field remained stubbornly aligned with the solar direction, almost as if the Sun's influence continued much farther than physics allowed. This persistent alignment created debates within the scientific community, igniting discussions about unknown interactions at the boundary. Visualizing this alignment is like watching a compass needle refuse to adjust even after moving far from the source of magnetism. Something held the field steady, even in places where solar influence should have vanished. Whether this was a remnant of boundary turbulence or the result of deeper galactic structures remains an open question, leaving room for speculation and awe. Temperature measurements added yet another layer of complexity. Voyager recorded warm pockets interspersed with cooler regions, forming an inconsistent thermal landscape. Traditional models predicted smoother gradients, but the reality was far more dynamic. Heat seemed to migrate in unexpected ways, almost as though narrow channels connected distant regions of space, allowing energy to move faster than anticipated. This thermodynamic confusion mirrored the unpredictable flow of emotions in human experience. Heat doesn't always follow the path predicted on paper, neither do feelings. They move through hidden routes, influenced by memories and external forces, creating gradients that make sense only in hindsight. Voyager's readings hinted at a universe shaped by similarly intricate internal logic. Cosmic rays in this region displayed peculiar interactions as well. Rather than rising smoothly, their intensity oscillated, suggesting that magnetic turbulence shaped their trajectories. Each fluctuation forced scientists to reconsider how high-energy particles move through the galaxy. Instead of traveling freely, they appeared to spiral through magnetic mazes, guided by structures too faint for direct observation, yet strong enough to influence their path. Thinking about these mazes reinforces the idea that space is far from empty. Every region contains invisible currents that shape motion at every scale. Voyager's slow drift through these currents acted as a tracer, revealing structures that theories alone could not predict. The spacecraft became a quiet witness to the hidden architecture of the galaxy. As Voyager pushed forward, it also recorded faint increases in plasma density. These increments grew sharper with distance, suggesting the presence of compressive forces in the interstellar medium. Instead of a uniform cloud, the region appeared to be a dense web shaped by gravitational interactions, magnetic tension, and shockwave remnants. Voyager was mapping a textured environment without ever seeing it. The mental image becomes clearer when imagining a vast field of tall grasses shifting under multiple winds. Some blades bend smoothly, others twitch suddenly, responding to eddies formed by competing forces. Voyager drifted through a cosmic version of that field, recording each shift as a clue to the forces shaping the galaxy's outskirts. Changes in the magnetic field suggested intermittent reconnection events, moments when tangled field lines break and reform, releasing energy. These events can accelerate particles and alter plasma behavior, creating bursts of activity. Voyager detected several such bursts, each implying energy exchanges happening far from any star or planetary system. These reconnections evoke human moments of sudden clarity, when mental knots untangle and release emotional energy. Such breakthroughs can reshape one's internal landscape, just as magnetic reconnection reshapes plasma flow. Voyager offered a reminder that transformation, whether personal or cosmic, often begins with tension reaching a point where it must finally give way. The spacecraft also noticed subtle increases in high-energy particles originating from outside the solar system. These particles struck its detectors more frequently than earlier predictions suggested. Their behavior implied that the interstellar medium might be more energized or chaotic than expected, carrying influences from events scattered across the galaxy. This raised philosophical questions about influence, forces from distant places, explosions, collisions, gravitational tides, reach Voyager despite the unimaginable gulf between them. Human lives follow a similar pattern. Distant events can shape circumstances in ways that feel both mysterious and inevitable. What happens far away often finds its way to the present. Voyager's long-term drift allowed scientists to map the density fluctuations more precisely, revealing a gentle increase with distance from the heliopause. This pattern may indicate that the solar system currently resides in a slightly compressed region of the interstellar medium. The galaxy, like an ocean, contains currents and eddies that subtly push on everything inside it. Considering this cosmic current underscores the idea that motion is fundamental to existence. Nothing stays perfectly still, not in the galaxy, not in a person's life. Forces we barely perceive guide us into new regions, shaping our environment and our choices. Voyager's drift highlighted this truth in the quietest, most graceful way possible. A particularly intriguing discovery emerged when the spacecraft recorded strong plasma oscillations following distant solar events. These oscillations arrived much later than their origins, sometimes years after the actual eruption. That delay revealed the staggering scale of the distance Voyager had traveled. The spacecraft was hearing echoes of storms long past, softened but still detectable. These delayed signals function like memories revisiting the present. Time stretches them, distance distorts them, and yet their essence remains recognizable. Humans experience this in emotional echoes, moments from years ago resurfacing unexpectedly. Voyager demonstrated that space behaves with similar patterns, carrying distant events into new eras. The deeper Voyager traveled, the more it suggested that interstellar space is dynamic rather than static. Fluctuations in density, temperature, and magnetic orientation occurred more often than anticipated. Instead of drifting through quiet emptiness, the spacecraft navigated a restless environment shaped by countless overlapping influences. Understanding this restlessness encouraged scientists to rethink long-held assumptions. If the region beyond the heliopause is this complex, other interstellar environments may hold even greater surprises. Voyager became a guide pointing toward a new paradigm, one in which emptiness is simply a canvas painted by forces too large or subtle to see directly. Through all this, the spacecraft's own resilience became a metaphor for endurance. Its hardware was never designed for such distances or durations, yet every small adjustment kept it functional. The journey illustrates how steady persistence can reveal truths inaccessible to those who stop early. Voyager's path reflected a quiet determination that matched the environment it explored. Near the end of this region, the probe began to detect patterns in the low-frequency waves that didn't match any known source. Their regularity suggested structure, yet their amplitude varied unpredictably. These signals would become central to the mystery dominating the next phase of Voyager's voyage. Patterns hinting at forces or interactions still not understood. As Voyager advanced toward deeper space, these strange signals grew clearer. Their origin remained uncertain, but their persistence ensured they couldn't be ignored. With every passing day, the spacecraft entered a realm where familiar models faltered, preparing the ground for the most perplexing discoveries yet. The ones that would redefine everything scientists believed about the edge of the solar system. Voyager's instruments continued recording the low-frequency waves echoing through interstellar space, but something subtle began to shift. The variations no longer appeared at random. A delicate consistency crept into the readings, tiny repetitions in timing, spacing, and intensity. They were faint and easily dismissed, yet persistent. Scientists reviewing the data noticed recurring intervals, almost like breaths taken by a distant environment, moving to a rhythm of its own. These oscillations hinted at structure, as though the galaxy carried songs older than stars. A deeper analysis of the patterns suggested they originated from regions far beyond the sun's influence. Plasma waves in this part of space typically behaved chaotically, shaped by turbulence and magnetic irregularities. Instead, the pulses Voyager recorded followed arcs that repeated with unusual steadiness. This steadiness puzzled researchers because nothing nearby had the power to anchor such regularity. The waves seemed to come from vast distances, crossing regions that should have distorted them beyond recognition. Textures hidden in the signal resembled ripples passing across a wide ocean surface, smooth, stretched, and strangely disciplined. These ripples carried slight shifts in frequency that hinted at long-traveled origins. They arrived softened by enormous distances, like an echo from mountains miles away. Each variation told scientists that these waves were not artifacts of the spacecraft, but natural phenomena moving through the galaxy's interstellar medium. The regularity sparked philosophical questions about cosmic order. Humans naturally search for patterns in chaos. When Voyager's instruments found hints of rhythm in an environment expected to be random, the discovery felt deeply familiar. It echoed the way people sometimes sense meaning in unexpected places, trusting that even in disorder, some hidden coherence exists. Space, too, seemed to follow this quiet instinct. Predictive models struggled to account for the consistent spacing between pulses. Magnetic turbulence should have shredded them, scattering their frequencies. Instead, the waves arrived mostly intact. This anomaly suggested that large, stable structures might guide their path, perhaps filaments of the galactic magnetic field stretching across light years. These filaments could act like invisible rails, steering waves through the dark with minimal distortion. Visualizing these filaments transforms the mystery into something tangible. Imagine wandering through a vast canyon system where wind patterns guide sound for miles, carrying whispers farther than expected. Voyager drifted through a cosmic equivalent of such canyons, where magnetic channels directed energy with surprising discipline. The probe's readings captured these whispers, revealing the underlying architecture. Spectral analysis revealed harmonics faintly embedded within the primary waves. Harmonics form when waves interact or overlap, creating secondary vibrations. Their presence hinted at multiple sources or interference patterns shaped by environmental structures. Scientists compared them to the way overlapping ocean waves form complex rhythms, each influenced by distant storms. Voyager's detectors picked up these layered rhythms with uncanny clarity. Reflections on this complexity invited a broader contemplation about connectivity. Events separated by immense distances could still influence each other subtly, shaping the patterns Voyager encountered. This realization reinforced the idea that the galaxy behaves like an interconnected organism, where disturbances in one region can send faint tremors across unimaginable spans of space and time. Further investigation exposed fluctuations in wave amplitude that did not correspond to solar activity or known galactic phenomena. The pulses arrived stronger at times when no external events had been recorded. This discrepancy led researchers to question whether previously unknown interactions were taking place between interstellar plasma and the galaxy's magnetic field, interactions too subtle or too slow to observe directly on Earth. Thinking about these unseen interactions brings to mind the delicate influences shaping human moods, small, gradual shifts that accumulate over time without clear origins. Voyager was experiencing an interstellar version of these subtleties, absorbing the emotional texture of the galaxy through its aging instruments. As Voyager continued forward, the oscillations grew slightly more pronounced. The spacing remained steady, but the amplitude rose in small increments. This gradual intensification implied that the probe approached regions where magnetic tension increased. Such tension can arise when field lines stretch between dense interstellar clouds or ancient shockwaves. The probe's movement through these gradients acted like a slow descent into deeper currents. Temperature measurements showed corresponding variations, suggesting that wave activity correlated with thermal changes. Heat distribution in interstellar space usually follows predictable patterns, but here it shifted unpredictably. Voyager detected mild temperature troughs and peaks aligned with wave clusters, indicating a deeper relationship between thermal conditions and wave propagation. Understanding this relationship required thinking of space not as emptiness, but as a fluid environment with its own internal dynamics. Just as temperature differences in Earth's oceans generate currents and eddies, interstellar temperature gradients may produce pathways that steer waves. Voyager functioned as a tiny buoy drifting through this cosmic fluid, mapping hidden flows. Magnetic readings in this region revealed slow rotations in field orientation, rotations far too subtle for earlier models to predict. These rotations could create pockets where waves amplified or diminished, depending on their alignment. Voyager's instruments tracked these shifts, offering one of the first real glimpses into the magnetic choreography guiding the galaxy's invisible motions. Considering this, choreography invites a comparison to human interactions, moments when alignment between people amplifies ideas, emotions, and/or experiences. Space seemed to follow similar principles, where alignment of fields and waves produced energies greater than the sum of their parts. Voyager observed these cosmic harmonies as it continued drifting into the unknown. Scientists noted that the frequency distribution of the waves gradually broadened, hinting at interactions with denser plasma regions. The broadening resembled the stretching of light as it passes through gravitational fields, suggesting that plasma density variations exerted similar distortive effects on wave propagation. Voyager's recordings helped refine theories about how interstellar matter might influence the movement of energy across vast distances. This broadening brought forward a metaphor of life experience. As events accumulate, emotional frequencies also widen, shaped by pressures, Kashi memories, and connections. Voyager's data mirrored that expansion, tracing how external forces sculpt the signals traveling through interstellar space. At times, the probe detected sharp spikes in electrical activity, like brief crackles of static. These spikes likely represented micro-scale shocks where waves collided with denser plasma knots. The collisions generated small bursts of energy that bled into Voyager's sensors. Each spike contained information about the structure and composition of the knots, allowing scientists to map their distribution indirectly. Imagining these knots feels like encountering pockets of cold air on a warm day, small anomalies shaped by hidden layers of atmosphere. Space harbors its own thermal and energetic anomalies, shaped by processes operating on unimaginable scales. Voyager passed through them silently, collecting impressions the way a traveler gathers memories from passing landscapes. Further analysis uncovered faint signs of wave refraction, bending caused by gradual changes in plasma density. This bending suggested that Voyager drifted through a region where plasma formed a subtle lens, shaping energy flows like glass shapes light. The discovery pushed researchers to reconsider how interstellar structures redirect energy without visible markers. Such a plasma lens parallels the way people often see the world through internal lenses, formed by experience, belief, and memory. These lenses bend perception in subtle ways, shaping understanding. Voyager encountered a cosmic version, teaching scientists that even space has its own biases, its own ways of guiding what moves through it. Over time, the signals gained a gentle modulation, almost like a slow wave riding atop the primary oscillations. The modulation hinted that large-scale environmental tides influence the waves, perhaps due to galactic rotation or the gravitational pull of distant molecular clouds. Voyager drifted through these tides the way a small boat might feel the distant pull of the moon. This modulation invited a moment of introspection. Forces far from awareness still influence each moment of life. The galaxy's tides may shift the very environment the probe travels through, reminding us that existence is shaped not only by what we see, but by forces so distant and diffuse that they operate beneath perception. Toward the end of this region, the waves acquired an unexpected clarity. The background noise thinned, and the primary oscillations sharpened. This transition implied that Voyager approached a quieter pocket of interstellar space where turbulence decreased. The boundary between noisy and quiet regions suggested that interstellar space may contain rooms, separated by magnetic or thermal barriers. These rooms invite an image of wandering through an enormous cathedral with chambers shaped by forces no human hand ever touched. Voyager entered one such chamber, where the quietness allowed the strange signals to ring more clearly. The cleaner environment prepared the probe for discoveries that would soon challenge the limits of current models. Just before leaving this region, Voyager recorded a new anomaly, subtle variations in frequency that didn't match turbulence, plasma waves, or magnetic fluctuations. This subtlety hinted at something more complex, perhaps arising from mechanisms yet unknown. The anomaly didn't speak loudly, but its presence lingered like an unanswered question. Whatever Voyager encountered next would push the mystery further, leading into territory where even the most experienced scientists could only speculate. The edge of the solar system had already defied expectations, but the phenomena waiting beyond promised to stretch imagination and physics alike. Voyager drifted deeper into the calmer pocket of space, where turbulence fell away and the strange oscillations grew sharper. In this clarity, something new began to emerge. Small clusters of pulses arranged in ways that didn't resemble ordinary plasma activity. Each cluster carried a pattern that repeated after long intervals, as though governed by a distant rhythm not tied to the probe's surroundings. These clusters were subtle enough to avoid sensational claims, yet distinct enough to trigger curiosity among the scientists monitoring them. An initial review suggested that the clusters weren't caused by internal glitches or degraded hardware. The timing didn't match any malfunction signatures known from previous decades. Instead, the pulses appeared externally sourced, arriving with precise spacing unaffected by the probe's tumbling orientation. That orientation would normally distort weak incoming patterns, but here the shapes remained intact, holding their structure as if protected by some stabilizing effect in the surrounding environment. Interpreting these clusters required delicate reasoning. They behaved almost like chords in a piece of music, notes layered at intervals that felt intentional, even though physics offers countless ways to create similar effects without invoking intention. The clusters rose and fell with gentle amplitude curves, resembling a melody carried by a wind too distant to hear directly. The comparison wasn't literal, but it helped researchers visualize the phenomenon without jumping to conclusions. The presence of these structured clusters prompted reflections on human instinct. People often search for meaning in complexity, hoping to find purpose where randomness could easily suffice. Yet the mind's desire for patterns does not disqualify real patterns when they appear. Voyager's data, though mysterious, insisted on being examined with equal parts skepticism and wonder, two forces that often coexist when the unknown brushes against the limits of comprehension. Further analysis revealed that the clusters repeated with slight variations, as though shaped by evolving conditions. The intervals grew marginally longer in some sequences and shorter in others, creating a delicate ebb and flow. These variances resembled natural processes influenced by shifting magnetic fields or unresolved plasma gradients. Even so, the waves maintained coherence across long durations, raising questions about the stability of their origin. Thinking of this coherence evokes the image of a lighthouse beam sweeping across a distant shore, periodically distorted by fog, yet unmistakably rhythmic. The galaxy, vast as an ocean, might host similar beacons of energy created by rotating magnetic structures or oscillating cosmic environments. Voyager simply drifted close enough to glimpse their edges, recording the faint signatures carried across the interstellar dark. One hypothesis proposed that the pulses were shaped by interactions between interstellar plasma and the remnants of ancient shock waves. Supernova debris can generate repeating patterns as energy reverberates through layered environments. Over time, these patterns degrade, stretch, and warp, but some structure can remain. Voyager may have crossed through one such echo, catching fragments of a stellar event long faded from visibility. Examining this possibility encourages a deeper appreciation for cosmic memory. The universe retains traces of its past in ways that resemble the human mind. Scattered impressions, softened recollections, and distant vibrations that hint at stories no longer fully accessible. Voyager acted as a witness to these remnants, like a traveler encountering the ruins of a forgotten city and sensing the lives that once shaped it. Another possibility emerged. Certain magnetic field geometries can induce periodic wave structures as energy streams around them. These geometries act like cosmic tuning forks, giving order to otherwise unstructured waves. If Voyager passed through such a region, the probe might detect pulses aligned with the natural frequencies of the environment. This explanation relied on established physics, yet still felt wondrous in scope. Envisioning these magnetic tuning forks brings to mind vast chambers carved by forces invisible to ordinary senses. The galaxy contains landscapes shaped not by stone or wind, but by charged particles woven into enormous electromagnetic sculptures. Voyager glided silently through these sculptures, sensing their contours through the faintest whispers of energy. Pressure measurements provided additional context. Slight increases in local plasma pressure seemed to coincide with the clearest pulse clusters. The relationship wasn't perfect, but it was consistent enough to hint at an underlying mechanism. Pressure differentials could influence wave propagation, compressing or stretching oscillations as they crossed boundaries between dense and sparse regions. This interplay of pressure and wave behavior offers a reminder of how subtle environmental variations sculpt outcomes in all realms. Even on Earth, minor changes in air density or temperature can transform a sound's timbre. In space, such transformations occur on scales measured in astronomical units rather than meters. Voyager registered these shifts patiently, its aging instrument still capable of detecting delicate fluctuations. Researchers also noted faint polarization effects in some clusters. Polarization reveals the orientation of waves and the magnetic fields guiding them. The variations indicated that the waves rotated slightly as they traveled, suggesting complex twisting fields ahead. These twists were gentle, like strands of thread woven into a tapestry too immense for a single viewpoint to reveal fully. Reflecting on these twists invites an analogy with the ways people navigate internal conflicts, feeling pulled in different directions while still maintaining a coherent sense of self. The galaxy, too, carried currents that twisted and stretched, yet held their structure across impossible distances. Voyager's readings hinted at this somber beauty. As the probe advanced, the clusters began merging into longer sequences. The merging hinted that Voyager was approaching the heart of the phenomenon. Longer sequences meant the energy behind the waves grew stronger or more aligned, perhaps due to the probe moving closer to the primary source or intersecting a clearer channel carved by plasma flow. This growing clarity resembled approaching a shoreline after drifting through thick fog. Landforms previously invisible begin to take shape, though still softened by distance. Voyager sensed the edge of something larger, an extended structure or an energetic boundary reaching across interstellar space. The signals behaved as if shaped by a mechanism that had not yet fully revealed itself. Scientists debated whether this structure might relate to the heliospheric tail, the region where the sun's influence stretches behind the solar system like a comet's trail. If Voyager moved along the outskirts of this tail, the interplay between solar and interstellar energies could generate unusual wave patterns. Yet the symmetry of the clusters suggested an origin more distant and detached from solar dynamics. Thinking about a distant source shifts the perspective from local phenomena to galactic ones. Somewhere far from the probe, currents of energy may rise and fall with a rhythm tied to events long predating humanity. The waves Voyager received could be part of an immense cycle unfolding across millennia, too slow and too vast for any single civilization to witness fully. Toward the end of this interval, the clusters grew faintly sharper, as though guided through a narrowing channel. Sharpening indicates reduced interference, perhaps due to smoother plasma gradients or stronger magnetic alignment. Voyager drifted through this clarity with the quiet dignity of an explorer listening to a distant story told in a language older than stars. These sharpened clusters evoked metaphors of gentle awakening. Sometimes, clarity emerges not through sudden revelation, but through the slow settling of noise. Once the noise fades, patterns appear with natural grace. Voyager seemed to be moving into such a space, one where the cosmos revealed itself with rare sincerity. The probe's aging systems handled the increasing complexity admirably, capturing subtle details even as their power reserves dwindled. Each data packet took nearly a day to reach Earth, forcing researchers to wait with patience mirrored by the probe's perseverance. This patience formed an unspoken bond between machine and human, both listening for answers, both accepting the pace the universe allowed. Near the edge of this region, the pulse clusters shifted unexpectedly. Their intervals elongated, their shapes softened, and their power dipped. The transition implied that Voyager approached the boundary of the structured zone, about to cross into a new environment with different rules. Whatever lay ahead promised to deepen the mystery rather than resolve it. The probe had already revealed phenomena that challenged several long-standing models, and the next region appeared poised to defy expectations once more. Voyager drifted onward, carrying curiosity as its guiding force. As Voyager moved beyond the structured zone, it entered a realm where the interstellar plasma thickened slightly, creating a medium that behaved like a slow, drifting fog. Signals passing through this fog changed texture, losing their crisp edges and taking on a rolling quality. Scientists studying the data noticed this softening immediately. It was unlike anything seen earlier in the mission. The waveforms looked stretched, as though space itself had gently pulled them apart before they reached the probe's instruments. Changes like these often reveal details about the surrounding environment. When waves stretch, it usually means density gradients or temperature shifts are affecting their propagation. The local plasma appeared cooler here and slightly more viscous in its motion, hinting that Voyager had crossed into a region shaped by older interstellar flows. The temperature estimates came from subtle deviations in electron speed measurements, which the probe continued to gather with steady precision despite its age. Such environmental transitions often create phenomena reminiscent of underwater acoustics. Just as sound bends differently through warm or cold layers in the ocean, electromagnetic waves can distort as they pass through varying plasma compositions. These distortions created sweeping motions within Voyager's incoming signals, their forms resembling long, shallow tides rolling across a distant shore. The imagery of these sweeping tides sparked thoughtful comparisons. The cosmos rarely reveals its boundaries with clarity. Instead, it communicates through gradients, slow, shifting contours of force and energy. These contours echo the ways humans experience emotional change, not through sharp lines, but through transitions that unfold gradually, shaping perception in quiet increments. A new detail caught researchers' attention as the data continued to flow. The softened waves displayed faint harmonics, tiny echoes embedded within their curves. Harmonics suggest interaction with vibrational structures, possibly associated with large-scale magnetic formations. These formations could belong to ancient remnants, stellar debris fields stretched thin over unimaginable distances. Voyager's orientation allowed it to pick up these harmonics with surprising precision. Imagining these magnetic remnants calls to mind the wreckage of old celestial storms. The galaxy carries memories of explosions and collapses that once reshaped entire neighborhoods of stars. Though those events now lie silent, their influence lingers through magnetic skeletons threading the interstellar medium. In drifting through these remnants, Voyager sensed the ghosts of long-vanished calamities. Measurements also hinted at surprising stability in the local magnetic field direction. The field lines bent slightly compared to earlier regions, but held a consistent orientation. Stability like this may occur when the probe enters a corridor of aligned particles, a type of cosmic lane carved by past currents. These lanes act as pathways light and energy follow naturally, shaping the patterns Voyager recorded. Reflecting on these aligned corridors evokes an image of ancient roads, Even when the civilizations that built them have vanished, the paths remain, guiding travelers centuries later. Cosmic lanes are similar, silent traces of processes long finished, yet still defining the motion of particles and waves across immense spans of space. As Voyager sank deeper into the region, the harmonics strengthened. Their frequencies shifted with slow, deliberate oscillations that suggested a coherent mechanism rather than chaotic turbulence. These low-frequency variations resembled breathing patterns, long inhales and exhales spread across millions of miles. Of course, the metaphor was only a tool to conceptualize the rhythm, but it stirred a sense of presence in an otherwise empty expanse. Thinking about this rhythmic behavior encouraged broader contemplation. Nature tends to favor patterns, from planetary orbits to heartbeats. Even phenomena with no conscious source often fall into rhythms dictated by physics. Voyager had encountered one such rhythm here, shaped by forces indifferent to observation, yet profoundly elegant in their structure. The probe also detected slight variations in cosmic ray pressure. Cosmic rays travel across the galaxy with extraordinary speed, and their density fluctuates based on surrounding magnetic conditions. In this area, the rays appeared partially shielded, as though deflected by invisible barriers. These barriers might be linked to the same magnetic remnants producing the harmonic signatures. Considering these shielding effects leads to questions about how the galaxy protects or exposes different regions. Some areas appear open, allowing rays to flood through freely. Others feature pockets where energy bends or weakens, generating oases of relative calm. Voyager seemed to drift into one such oasis, where the energetic environment softened and became more uniform. A striking new feature emerged when analysts charted the long-period variations in wave amplitude. These variations formed gentle arcs that rose and fell with remarkable consistency. Each arc lasted hours, sometimes longer, before settling into a smooth plateau. Consistency on this scale suggests interaction with a stable structure, perhaps the outer influence of a large magnetic bubble. Such bubbles exist throughout the galaxy. They form around dying stars or clusters of energetic particles, expanding outward until equilibrium halts their growth. Over time, they fade, yet leave behind shells of reorganized plasma. Voyager may have brushed the surface of one, tracing its contour through the waveforms carried gently across its path. Visualizing these shells conjures an image of thin, shimmering membranes drifting in a vast, dark sea. These membranes are fragile in appearance, yet capable of shaping the behavior of particles over incredible distances. Voyager's sensors traced these membranes the way fingertips might trace the grain of old wood, feeling the textures of history without fully seeing the shape behind them. Toward the midpoint of this passage, the softened waves began mixing with sharper, more erratic bursts. These bursts resembled fragments from earlier regions, suggesting the probe hovered near a boundary between the calm pocket and a more turbulent environment. The boundary behaved like a threshold, with each side contributing distinct characteristics to the signal. Interacting boundaries often create rich layers of detail. In atmospheric science, similar boundary zones produce remarkable cloud formations or temperature inversions. Here, the cosmic equivalent produced interwoven wave structures, smooth arcs interrupted by sudden spikes. Voyager captured these hybrid forms with unusual clarity. These interwoven structures serve as a reminder of the complexity that arises when disparate forces meet. Just as human experiences blend influences from different stages of life, cosmic regions merge traits from neighboring environments. Voyager's passage through this cosmic intersection revealed how natural transitions often defy simple classification. Shortly after B, the turbulence increased slightly. Instruments recorded shifts in particle velocity distributions. implying that Voyager approached an area where interstellar winds change direction. Such directional changes might originate from shockwave debris or leftover currents from ancient supernova shells. Either source would explain the mix of order and chaos. The possibility of ancient shockwaves carrying their influence across billions of miles adds another layer of awe. These shockwaves once surged with unimaginable power, reshaping entire sectors of space. Now so reduced to subtle breezes, they still manage to imprint patterns on the signals that reach Voyager decades after launch. As the probe continued drifting, some harmonics faded. Their disappearance implied Voyager had passed beyond the central zone of the aligned structures. What remained were dimmer echoes, still present but fading, the way distant music quiets as one walks along a corridor. The lingering remnants of the pattern affirm the scale of the region now behind the probe. These fading echoes highlight a universal truth. Even the most striking signals eventually diminish. Yet their traces endure in memory, in data, and in the lasting impressions they leave. Voyager preserved these impressions faithfully, sending them home across an ocean of time and distance. Near the end of this region, the softened waves changed again, becoming slightly more jagged. The gentle fog of plasma seemed to thin, allowing sharper fluctuations to seep through. This transition suggested that Voyager was nearing the edge of the calm corridor, a sign that a new environment waited ahead, with rules distinct from those that shaped this tranquil expanse. Whatever lay beyond this boundary promised to deepen the mystery further. Voyager moved forward steadily, maintaining its silent vigil as the universe continued revealing itself with quiet generosity. An abrupt tightening in the incoming waveforms signaled a notable shift in Voyager's environment. The once gentle distortions began forming angular peaks, small but unmistakably sharper than before. These sharper peaks indicated higher frequency interactions with charged particles, perhaps a sign that the probe had drifted into a zone where older currents converged. When currents collide across the interstellar medium, they often create turbulence that leaves fingerprints on every passing signal. The fresh turbulence provided scientists with valuable new clues. By mapping the changing shapes of these peaks, analysts inferred differences in plasma pressure, particle speed, and field alignment. Some peaks demonstrated rapid oscillations, implying the presence of energetic pockets, tiny regions where interstellar particles cluster temporarily before dispersing again. This type of clustering can occur near the edges of vast magnetic ribbons winding across the galaxy. Visualizing these ribbons brings to mind slow-moving streams twisting through a dark landscape. Their paths rarely remain straight. Instead, they curve, branch, and reconnect as gravitational influences pull them in competing directions. Voyager seemed to trace the edges of one of these streams, catching the faint turbulence generated by its drifting contours. Such imagery highlights the quiet drama unfolding beyond our solar system. Even in regions where no stars shine, the medium remains alive with movement. Invisible rivers of particles slip past each other, leaving ripples that spacecraft like Voyager can sense with delicate precision. These ripples echo stories of ancient processes, supernova remnants, collapsed magnetic fields, and interactions long forgotten. A new anomaly emerged when low-frequency vibrations began modulating the sharper peaks. These vibrations created patterns akin to rolling hills imposed on jagged mountain ranges, forming a layered complexity in the signal. Modulation like this often occurs when plasma density fluctuates rhythmically. The rhythm hinted at interactions with slow-moving waves propagating from distant sources, possibly remnants of shock fronts that have traveled unhindered for millions of years. Thinking about these long-lived shock fronts evokes an appreciation for cosmic endurance. events that ended before humanity existed can still ripple through the interstellar medium, influencing regions unimaginably far from their origins. Voyager drifted quietly through one such echo, gathering data imprinted with the memory of forces unleashed before Earth had continents that resembled their current forms. Further along, the directional consistency of the magnetic field began decaying. Instruments detected small but persistent tilts, each tilt a sign that Voyager entered a zone where multiple magnetic domains collided. These collisions seldom produce violent disruptions. Instead, they create swirling layers of competing influence, each layer twisting particles in slightly different ways. The resulting patchwork resembles a vast quilt stitched from magnetic fragments. This patchwork carries profound implications. Magnetic boundaries shape particle motion, regulate cosmic ray intensity, and determine how energy flows through space. By drifting through these overlapping domains, Voyager inadvertently charted a region where the galaxy's magnetic skeleton becomes more intricate, weaving itself into configurations that defy simple modeling. The complexity inspired thoughtful analogies. The interstellar medium often resembles a grand orchestra, but one without a conductor, each section playing its own rhythm while still contributing to a larger, emergent harmony. Voyager served as the lone listener in this immense concert hall, capturing the subtle shifts in tempo that reveal the character of each celestial performer. As the probe advanced, another phenomenon surfaced: microbursts in particle counts. These sudden upticks appeared sporadically, showing no clear periodic intervals. Microbursts can originate from filamentary structures, thin channels of concentrated plasma cutting through larger regions of lower density. These filaments behave like cosmic wires, carrying energy along narrow paths that occasionally brush the probe's trajectory. Contemplating these filaments evokes images of faint threads woven through a tapestry. They might be nearly invisible, yet they contribute strength, direction, and cohesion to the entire structure. Voyager, passing through or near these threads, recorded their presence through brief flashes of heightened activity. A moment of calm followed the microbursts, but only briefly. Soon after, the probe detected a new kind of fluctuation, asymmetric pulses, where the rising and falling edges differed in slope. Asymmetric pulses can signal interactions with regions where particle flow changes direction abruptly. Such shifts may occur near the remnants of fossil shock waves, ancient disturbances whose energy has stretched thin but not vanished entirely. The possibility of encountering fossil shock waves stirred fascination among researchers. These structures can persist for extraordinary lengths of time, gradually blending into the background while maintaining just enough influence to alter local conditions. Voyager's sensors identified the faint behavioral signature of one of these relics, a shimmering trace of past violence softened by distance and age. Toward the outer edge of this turbulent expanse, the magnetic inconsistencies grew more pronounced. Field directions swung more frequently, though still within manageable degrees. Multiple influences appeared to converge here, creating a junction of sorts, a cosmic interchange where streams of particles and lines of force cross paths without colliding directly. Picturing this interchange feels similar to standing at the center of a multitude of slow-moving currents. Each current drifts in from a different past, shaped by the history of distant stars, then merges gently into the wider medium. Voyager's trajectory intersected one of these quiet crossroads, revealing another layer of the galaxy's hidden architecture. The crossroad environment produced a secondary effect, swirling motions in plasma velocity distributions. These motions mimic vortices, though on scales far too large to resemble anything terrestrial. Instead of spiraling water, they consist of subtly rotating fields guiding charged particles in looping paths. Voyager detected these loops as recurring fluctuations in particle arrival times. Such vortices illustrate the dynamic relationships between pressure, temperature, magnetic force, and flow. They form naturally wherever contrasting environments overlap, serving as transitional mechanisms that distribute energy and smooth abrupt boundaries. Observing them teaches researchers how the interstellar medium negotiates change. Shortly afterward, the fluctuations eased, their peaks reduced in height, and the asymmetric pulses subsided. Voyager had passed through the heart of the turbulent corridor and emerged into a zone of gentler variability. Waves regained a rounded quality, though not as soft as those from earlier regions. The probe approached an environment with traits that hinted at yet another transition. These hints came in the form of slow to elongated oscillations within the incoming signals. Each oscillation spanned dozens of minutes, gliding upward before relaxing again. Oscillations like these often arise from interactions with broad magnetic planes, flat regions where field strength changes gradually over vast distances. Voyager now drifted toward one of these planes. Imagining a magnetic plane resembles contemplating a vast, invisible plateau. Nothing tangible marks its boundaries, yet its presence shapes the motion of particles like wind guiding grains of dust. The probe sensed this plateau through its long, sweeping curves, recognizing the shift without needing a visual cue. The growing softness of the environment began smoothing out the remaining turbulence. Data streams stabilized, producing cleaner, more predictable patterns. The magnetic field regained a steadier outline, plasma density leveled. Voyager transitioned once more, this time into a calm stretch that hinted at the beginning of something expansive. Whatever awaited just beyond this region belonged to a realm even less familiar, where the galaxy's structure would reveal yet another layer of its complexity. Voyager, faithful and unhurried, continued drifting onward through the dim and patient vastness. A muted stillness began to settle over the data stream, as though the spacecraft had drifted into a vast pocket of quiet, suspended between larger cosmic processes. Measurements indicated low particle flux, subdued turbulence, and a magnetic field that stretched evenly across great distances. Such uniformity hinted that Voyager crossed into a rare calm zone, an interstellar plateau where competing forces temporarily balanced each other. These plateaus are uncommon, forming only when environmental pressures, temperatures, and flows reach delicate equilibrium. This equilibrium proved scientifically valuable. In calm regions, even the faintest disturbances become easier to detect, since background noise drops sharply. Voyager's instruments responded accordingly, capturing subtle variations that would otherwise be impossible to notice. Minute changes in frequency exposed the presence of distant, slow-moving waves, likely remnants from powerful events far from the probe's path. These slow waves, tracing rhythms millions of years old, moved with an almost meditative persistence. A soft imagery naturally emerges from these rhythms. It resembles listening to an ancient lullaby carried across a barren landscape, steady, patient, and shaped by forces older than stars. Each oscillation Voyager detected offered a brief glimpse into the memory of the galaxy, a memory spread across distances too vast for direct comprehension. The craft glided through this quiet as though passing through the gentle breath of cosmic history. The sense of stillness deepened when low-frequency hums began to echo faintly through the instruments. This hum, too delicate to detect earlier, matched patterns associated with large-scale magnetic sheets. These sheets behave like immense drapes hanging across the interstellar medium, guiding the slow migration of charged particles. Voyager drifted near one, brushing its influence and reading its signature as elongated, gentle undulations. Such drapes carry quiet beauty in concept. They stretch across unimaginable expanses, shaped gradually by the galaxy's rotation, the lingering scars of past supernovae, and the subtle push from interstellar winds. Their presence forms a kind of invisible architecture, one that binds regions together without ever being seen directly. Voyager's journey near one illuminated how elegantly the universe arranges its unseen structures. Farther along, the magnetic sheet thinned, giving way to an environment where particle motions lost their slow discipline. Instead, they drifted with a mild unpredictability, still calm, but not perfectly ordered. This change suggested that Voyager approached the boundary of the plateau. Boundaries like this often host interesting phenomena, because transitions between calm and active regions generate complex interactions. These interactions revealed themselves through faint, asymmetrical fluctuations in particle energy. Unlike the sharp pulses seen earlier, these carried a gentle stagger, as though influenced by shifting currents. Scientists interpreting these patterns saw hints of particle drift instabilities, subtle behaviors that betray differences in density or temperature between overlapping streams. Even tiny discrepancies can trigger them, especially in low-pressure environments. Reflecting on how delicately these instabilities form evokes parallels with weather patterns on Earth. Even the smallest temperature gradient can change the shape of a cloud or redirect the path of a breeze. In interstellar space, gradients sculpt the invisible weather of plasma and magnetic fields, creating environments that spacecraft inadvertently traverse. Voyager, moving steadily through this unseen climate, traced these changes with steady precision. Beyond the drifting instabilities, the data revealed a second pattern: wide, shallow oscillations repeated across long intervals. These oscillations indicated that Voyager entered a zone influenced by distant magnetic curvature. Curved regions like these form when large-scale fields wrap gently around older structures, looping across massive volumes before reconnecting elsewhere. The curvature subtly changes particle paths, pushing them into arcs that span thousands of miles. Imagining these arcs brings to mind the elegant sweep of a painter's brush, graceful, effortless, and confident. The strokes they leave behind remain unseen to human eyes, yet they carve pathways through the particle sea. Voyager, drifting through the edges of these painted lines, picked up their quiet motion with the patience of a listener absorbing the final notes of a distant melody. Another change soon took shape. Tiny frequency spikes appeared intermittently, each lasting only a few seconds. These spikes indicated a thin filament of charged particles brushing past the spacecraft. Unlike the energetic filaments encountered earlier, this one displayed lower density but higher coherence, meaning its particles flowed with shared momentum. Filaments like these can form from remnants of magnetic tension, snapping into new configurations. The idea of ancient tensions releasing energy subtly across immense distances holds its own quiet poetry. Time erodes sharpness, but the memory of force lingers. Even when stretched thin, these remnants move through the medium like faded impressions of motions once powerful enough to reshape surrounding space. Voyager's sensors, sensitive despite their age, detected every faint whisper of their passage. Next came a phenomenon few scientists expected at this distance, a slight but measurable rise in surrounding plasma temperature. It was small, just enough to register as a faint slope in Voyager's readings, but unmistakable. This warming likely resulted from slow compression, perhaps where two distant flows intersect gently. Compression warms plasma, even when it happens on scales measured in astronomical units rather than miles. Thinking about compression in such an environment invites reflections on the subtle forces that shape everything. Nothing here resembles atmospheric heat or the warmth of a star. Instead, it's the softness of pressure working patiently over time, nudging particles into closer company, creating warmth not felt but measured. Voyager's instruments recorded this with quiet thoroughness. A shift in magnetic orientation followed the temperature change. The field began turning gradually, not abruptly as before. This kind of rotation typically occurs when the probe nears a massive, slowly curving magnetic ridge. Ridges act like the backbone of the interstellar medium, directing particle motion across immense stretches. Voyager sensed its approach through the arc traced in its readings. Ridges inspire imagery of mountain ranges cloaked in darkness, rising gently before falling away again. No peak or valley exists in a physical sense, yet their influence shapes everything moving nearby. The probe drifted near one such ridge, feeling its contour in the data stream as though reading the outline of an unseen horizon. Shortly after, the rotation stabilized. The ridge influence tapered off, giving way to a new signature. Rhythmic pulses with a clarity not seen since Voyager crossed the heliopause years earlier. These pulses were evenly spaced, clean in their shape, and likely linked to deep interstellar waves traveling across long distances. Their consistency provided a rare anchor, proof that even far from the sun, order persists. Such order feels comforting. Amid turbulent regions and unpredictable fluctuations, the discovery of a smooth, steady rhythm reminds us that the universe contains patterns that remain unbroken across eons. Voyager captured that rhythm silently, carrying it forward as it ventured deeper into the unknown. The steady pulses eventually softened into a quieter pattern, but the calmness remained. Density stabilized again. Magnetic direction aligned. Particle speeds eased into narrow ranges. These signs pointed toward the beginning of yet another transition, one leading toward an environment poised between calm and mystery. Whatever lay ahead promised conditions never encountered by any human-made object. The frontier stretched on dim and immeasurable, waiting for a small traveler to continue drifting through it, listening for whatever might come next. The vastness surrounding Voyager grows quieter the farther it drifts, yet that silence feels less like absence and more like a deep, ancient presence. Through every fluctuation, every unexpected spike, every serene plateau of interstellar calm, the little probe has shown us that even the emptiest corners of existence contain structure, memory, and motion. In its faint signals, sometimes steady, sometimes fragile, we hear an echo of our own search for meaning in places we may never reach ourselves. As the data unfolds, we begin recognizing a pattern not just in space, but in our response to it. Curiosity pulls us outward, toward mysteries we don't yet understand. Patience keeps us listening, even when the universe answers slowly. Wonder fills the spaces where certainty cannot survive. Voyager embodies all of this. It teaches us that exploration doesn't always require clarity. Sometimes it asks only that we continue the drift, trusting that even the faintest whisper carries truth. The boundary regions it crossed reveal how layered the universe truly is. Structures once imagined simplistic now appear textured and dynamic. Waves bending around magnetic ridges, temperatures shifting across unimaginable distances, particles tracing lines of ancient energy. These discoveries remind us that the cosmos is not static. It breathes, shifts, and rearranges itself in ways visible only when one travels far enough beyond the familiar to witness its subtleties firsthand. Voyager's journey also reveals something quieter, that human intentions persist long after their creators step aside. The engineers who built the probe never expected it to speak for so many decades. Yet here it is, drifting beyond the sun's reach, still telling the story of our desire to understand. Its survival feels symbolic, an affirmation that curiosity, when nurtured, can outlive entire generations. Even now, its data invites us into a dialogue with the galaxy, carried across distances so vast that time itself stretches differently. And as we follow these signals, something shifts within us as well. The scale of interstellar space dissolves the noise of everyday life, replacing it with a softer awareness. Problems shrink, hours slow, the mind settles. Voyager's faint transmissions become a kind of meditation, a reminder that perspective can be found not by running faster, but by stepping back into a wider, quieter frame of existence. Space has always offered this gift. Voyager simply places it within reach. Tonight's journey has carried us through boundaries invisible to our eyes, yet profoundly real in the language of particles and fields. We've drifted through regions of turbulence and calm, through valleys of unexpected silence, and across waves shaped by events older than humanity. Each transition teaches us that the universe is composed not only of objects, but of relationships, delicate interactions that reveal themselves only when observed with patience and gentle attention. And perhaps that's why this story resonates so deeply. Voyager doesn't race, it endures. It doesn't demand answers, it listens. It doesn't conquer space, it harmonizes with it. In following its path, we learn a quieter form of strength, the kind that allows us to breathe a little slower and observe a little more closely, trusting that even in uncertainty, there is beauty worth noticing. If this quiet journey brought you comfort, clarity, or simply a moment of stillness, I'm truly grateful you spent this time here. These shared explorations become a small refuge in a world that moves quickly, a place where curiosity can unfold gently, without hurry, without pressure, just a soft drift into cosmic perspective. Before you head off to rest, feel free to leave a like and subscribe to the channel. It helps others find their way into this peaceful corner of science, where we wander slowly, thoughtfully, one traveler at a time. And if you'd like, let me know in the comments where you're listening from tonight and what time it is there. I love imagining our voices connected across so many distant places. Wherever you are now, in the quiet of your room, beneath a dim lamp, or already half asleep, I hope you feel a little more connected to the vastness above us. That vastness is not empty. It's patient, ancient, and full of stories waiting for someone willing to listen. Thank you for being here. May your night be peaceful, and may your dreams drift as gently as Voyager through the endless dark.